In this video clip, I'm going to show you how to do problem 3. In problem 3, you are supposed to describe a set of solutions for the system which has infinitely many solutions, right? So this is A and this is B vector. Now, to show that, I actually changed the format to rational because I don't want to get round of error as much as possible. This is A, this is B. I do LU factorization on U, and let's see what happens up to here. Alright, so here is L, here is U, and you see a star actually showing up here, and this is P. Now, this is star is actually it's pretty much 0, because if you do U33, you see that it's a very small number. Now, because MATLAB cannot show that as a 0, it actually shows it as this rational number. Since I know that the exact value for U33 is 0, I just set this manually equal to 0 over here. Alright? Now, with that, to solve for x, you have to do it in 2 steps. First, you have to solve for y through Ly equals Pb, right? And then in the second step, you do ux equal to y. First, you solve for y, and then you solve for x. Now, to solve for y, basically you do backslash operator of L and Pb using this equation, right? And then after you solve for y, you find x through backslash substitution using u vector. Now, let's see what u is. So I'm going to stop the code right there. Alright, so here's my y, right? It's 5, 2, or 7, and then this is basically 0. MATLAB cannot show it. It shows as this fractional number. So, since I know y is 0, well, the last element of y is 0, I set that manually equal to 0. Okay? Well, I'm going to do it later on. Now, the rest of this would be after you get y vector, right? Then you need to solve for x using basically ux equal to y. Now, if you're careful enough, you notice that the third element of x is actually the third element of y from here, divided by u33 through back substitution. Now, since u33 is 0 and u31, y31, which is this number, and this is also 0, you get 0 by 0, and that means x is not a number. So since x is not a number, I can set it to any number I want. Let's say we call it t, okay? So here I'm going to do the rest of solution symbolically because there's a t involved in there. Okay, so I clear my y vector. I introduce t as a symbolic variable. Then I introduce y back again with the same first 2 elements. And in the last element, I'm going to substitute t, okay? So let's do step, step, step. Now, since u33 is 0 here, right, the solution to that would be undefined if I leave it as, if I leave it as 0. So I'm going to change u33 to 1 just to simplify the calculation, but this doesn't change the solution, all right? So I set u33 equal to 1, and then I solve for x. Okay, so let's see what x is. Well, let's do pretty display. Alright, so here is x, right? So you see it has t in it in all 3 elements. So basically what we did was we assumed the third element of x here is t, and then we find the other 2 elements of x in terms of t. Okay, so now you have this as a set of infinitely many solutions. So t can be any number, you can put any number there, and then the final would be the solution. Okay, so that is part 1. Now part 2, it's suppose gas elimination is used to solve this. Because there are infinitely many solutions, it's unreasonable to expect one particular solution, as we saw before. What happens? Well, I guess I explained it. What happens is you get actually x31 equal to y31 divided by u33, and both y31 and u33 are 0. So you get 0 by 0, and that is not defined. Okay, so because of that, you get the third element of x as not a number. Okay, so this is what happens. Now in part 3, I ask you guys to do backslash operator to find x. Okay, now if you do that in MATLAB, what you obtained is, okay, let's see what we do. So what I'm going to do is I'm going to comment these out because these are symbolic solutions, and then go back to here. So even comment this out and comment this out. Okay, so let's add x equal a factors like b. Okay, see what happens. So we get something, right? Well, we get an error, actually warning, and it says matrix is very close to singular, and this is good news because we know that matrix is close to singular and the condition number is very small. On top of it, we get a solution for x, which is strange because we found that there's infinitely many solutions, and we should not expect one, but MATLAB gives at least one solution. And the reason for that is actually right here. Since y31 and u33 both are non-zero in MATLAB, they're very small numbers, when you divide one by the other one, you get actually a finite number. Okay, so let's do this. Let me actually comment this and redo these parts and then show you what happens. Okay, so right. So instead of rational, I'm going to change this to short engineering format. Okay, then you can see how MATLAB represents zero. Okay, there you go. See, this is y33, the third element of y, right? So the third element of y is supposed to be 0, but it turns out to be a very small number because MATLAB cannot represent 0 exactly. Now, what is u33? Well, I can actually type it here. So this is u33. You see that that is also a very small number. Now, to get x31, you need to divide y31 by u33. So let's do that. I'll cut this and paste it over here. And now you see that when you do that, this is what you get, right? And this is because y31 is very small. u33 is also small. You can see them over here. So this is y, this is u33, and when you divide this by that, you get almost, something close to 0.004. And because of that, x3 is not a generic number like t, what we assumed before. It's a number, and then the back substitution actually goes through with this x3 and then finds the other values. Okay, so that's why MATLAB gives this solution, because it cannot represent 0 as exactly or as accurate as we do on paper and pencil. Now, why this is a good solution? Because first of all, it gives an error, so we know that there is a possibility for singularity in the matrix. And then second of all, the residual using this is very small. So what residual is actually, so we can define residual as a times x minus b, right? So this should be capital X, like so. And there we go. So the residual, you see that is very, very small. So it satisfies the equation, actually, and it also gives us this error. And because of that, it's a good solution. So hopefully that solves problem 3.